Our universe is a fascinating and mysterious place. We, as humans, have an innate desire to understand it, to unravel its secrets. But what if the very act of observing the universe changes it? This is the intriguing concept behind the observer effect. It is a principle that spans various disciplines, from quantum mechanics to psychology. It suggests that the act of observing a phenomenon inevitably influences the phenomenon itself. This concept, while seemingly simple, has profound implications for how we understand the world around us. It challenges our perception of an objective reality, suggesting that we are not merely passive observers, but active participants in shaping the reality we observe. Whether we are studying the behavior of subatomic particles or the dynamics of human interaction, the observer effect demonstrates to us that our presence, our methods of observation, and even our expectations can influence the outcome of what we observe. The observer effect takes center stage in the fascinating realm of quantum mechanics, the study of the very small. Here, the laws of physics take on an almost magical quality. Particles like electrons and photons behave in ways that defy our everyday intuition. They exist in a haze of probability and uncertainty. One of the most famous experiments demonstrating the observer effect in the quantum world is the double-slit experiment. Imagine shining a beam of light, not at a solid wall, but at a wall with two narrow slits. On a screen behind the wall, you wouldn't see two simple lines of light as you might expect. Instead, you would see an interference pattern, a series of light and dark bands. It is as if the light waves passing through the slits were interfering with each other like ripples on a pond. Now imagine you could fire single particles of light, photons, one at a time. Logic might tell you that each photon would pass through one slit or the other, creating two bands of light on the screen. Surprisingly, this isn't what happens. Here's where the observer effect comes in. If you place a detector at one of the slits to determine which slit each photon passes through, the interference pattern disappears. The act of observing, of measuring which path the photon takes, forces it to choose one path, destroying the wave-like interference pattern and behaving more like a particle. This mind-boggling behavior of the quantum world suggests that observation is not a passive act. It has a direct and measurable impact on the system being observed. This challenges our very understanding of the nature of reality, and this experiment has profound implications, not just for physics, but for our philosophical understanding of the universe. It suggests that at a fundamental level, the universe is interconnected in ways we are only beginning to understand. The observer effect also plays a crucial role in the development of quantum technologies, such as quantum computing. These technologies promise to revolutionize fields from cryptography to material science, leveraging the unique properties of quantum mechanics. The observer effect, particularly as demonstrated in quantum mechanics, leads us to a profound and perhaps unsettling question. Does observation create reality? This question has intrigued scientists and philosophers for decades, pushing the boundaries of our understanding of the universe. Does the universe exist in a nebulous state of possibilities until an observer collapses those possibilities into a single outcome through the act of observation? Or is there an underlying reality that exists independently of our perception? In the quantum world, particles exist in a superposition of states, a kind of blurry existence where they are potentially in multiple states at once. This superposition is a fundamental concept in quantum mechanics. It illustrates the strange and counterintuitive nature of the quantum realm. It is the act of observation, of measurement, that seems to force these particles to choose a definite state, collapsing the wave function, as physicists call it. This collapse is what transforms the potential into the actual, the possible into the real. This concept challenges our everyday understanding of a concrete, objective reality. It suggests that what we perceive as solid and unchanging might be far more fluid and dynamic than we ever imagined. It suggests that reality at the quantum level is not a fixed entity, but rather a fluid, dynamic process that is intimately intertwined with the act of observation. This fluidity is reminiscent of the ever-changing patterns in a flowing river or the swirling of liquids in a container. This idea has captivated philosophers and scientists alike, leading to various interpretations of quantum mechanics. Some see it as evidence of a deeper, hidden layer of reality, while others view it as a fundamental aspect of the universe's nature. While there is no definitive answer to the question of whether observation creates reality, the observer effect compels us to rethink our role in the universe. It challenges us to consider the possibility that our very act of observing might be shaping the world around us in ways we do not yet fully understand. Perhaps, as the philosopher George Berkeley suggested, to be is to be perceived. This radical idea proposes that existence itself is dependent on being observed. It is a notion that has profound implications for our understanding of reality. Or perhaps, reality exists independently of observation. Our act of looking therefore shapes our understanding and experience of that reality. This perspective suggests that while the universe may have an objective existence, our perceptions and interpretations are what give it meaning and context. Whatever the answer, the observer effect stands as a testament to the profound and mysterious connection between the observer and the observed. It invites us to explore the depths of this relationship and to ponder the true nature of reality itself. Moving from the realm of the very small to the world of human behavior, we encounter the observer effect in a different light. Here, it is not subatomic particles that are affected by observation, but rather the behavior of people. The Hawthorne effect, named after a series of experiments conducted at the Hawthorne Works factory in the 1920s and 30s, demonstrates that individuals often modify their behavior when they are aware of being observed. In the original Hawthorne studies, researchers were interested in understanding how changes in working conditions, such as lighting and break times, affected worker productivity. They concluded that the workers' awareness of being observed, of being part of a special study, was the primary factor driving the increased productivity. The Hawthorne effect has since been observed in various settings, from classrooms to hospitals. It highlights the powerful influence of observation on human behavior. When people know they are being watched, they may consciously or unconsciously alter their behavior and their body language, often to conform to perceived expectations or to present themselves in a more favorable light. This phenomenon has significant implications for research in the social sciences, where understanding and accounting for the observer effect is crucial for obtaining accurate and unbiased data. What do you think about the observer effect? Have you ever observed anybody and noticed it has had a dramatic change on their lives? Drop a comment. But for now, it's a wrap, folks. Please don't forget to like and subscribe for more engaging science and psychology content, and have a fantastic and blessed day.